Hello, can everyone see my screen? I hope so. Um, and hopefully you can hear me as well. Anyone? Okay, so it's probably going to be 20 seconds or so until I actually see anything in the chat because YouTube is slow. Yeah, so yeah, this will be recorded. This talk will be recorded, Santiago. Hi, welcome. Welcome to tonight's UQCS talk, the Tech Talk, Programming Perfect Documents. This is normally a bit weird. This is a bit weird because I'm normally normally introducing the presenter, but this time I'm actually the presenter. So yeah. Hi, I'm Matt. I'm the secretary of UQCS. I'm a third-year computer science and math student, and I'm very passionate about LaTeX. I love this wonderful tool, and in general, this is my favorite thing to talk about. So finally, I've had the opportunity to talk about it. How wonderful. Thanks, Raggy. Appreciate it. So yes, this is LaTeX, and hopefully by the end of this roughly 50 or so minute talk, you'll have a much better understanding of what LaTeX is, and maybe even be able to start writing some of your own tech stuff. So, without further ado, let's get started. Oh, by the way, also feel free to ask any questions during the night. I'll be happy to answer them. Yeah. Or I can take them at the end. I mean, if it doesn't interrupt too much, I'll be happy to take them as they come along. So, this is a motivating example / meme. Many of you have probably experienced this when you create a Word document for your assignment or your homework or your essay or whatever. This may be something that you might be able to relate to. It's a bit of a pain. Text wrapping, that sort of thing, moving images around, formatting is just a bit of a pain. And yeah, this is caused mostly by the fact that Word is a editor where you have to actually drag stuff around. You have to focus on the layout rather than the content, essentially. And you need to do a lot of layout work on your own to get an appealing document. And that's where LaTeX comes in. The idea with LaTeX is that we want to shift the focus to content. Let LaTeX do all of the formatting, let LaTeX do all of the page layout, and we can do the content, right? We can write that assignment or whatever, right? So, hang on, give me a sec. Yep, okay. So, what is LaTeX? What is TeX? What's the difference? Okay, before we explain that, this is the outline of tonight. I'm going to see how much of this I can get through, hopefully all of it, but that might depend on how my pacing is. But let's see. Okay. LaTeX is a document typesetting system. That's just a fancy way of saying you put shit in it and then out comes a document. PDF in LaTeX case. In Word, you get a docx file and then you can export it to PDF or whatever, right? TeX is the programming language underlying it, right? And as you may have noticed, I'm not saying LaTeX and I'm not saying TeX. It's pronounced LaTeX or LaTeX depending on who you talk to. I just say LaTeX, but it doesn't really matter as long as you don't say LaTeX. But yeah, so TeX is the programming language, LaTeX is the system. I will use them interchangeably because pretty much everyone uses them interchangeably and doesn't realize. And it's not really important for the sake of this. It's just, this is the terminology, yeah. So this is basically what LaTeX is. You give it a file, a source file, as it's commonly known, which is TeX code, and that's a .tex extension, and then you feed that into the LaTeX compiler, and it gives you an output. So it's much like a programming language, like if you wrote Java, or maybe, what's a simpler example? C, right? You give it code, you write source code, right? You feed it through the compiler and it gives you an executable, right? This is essentially the same thing, except your executable is your PDF output. I am massively simplifying things here, but for the purposes of an introductory talk, that's basically what it is, right? So how do we get through all of these steps? Well, the first thing is to edit text, you don't need anything fancy. It's just text, right? Any text editor will do. VS Code is a popular one. Vim and Emacs, if you're so inclined, are all popular options. And there are also IDEs for text. So there's Text Studio, TeXmaker. There's also one I use called TeXpad, which is a Mac exclusive one. But the point is, it's just a text file. You can edit it in whatever way you please. The compiler itself, the most common one that's used by people is PDF LaTeX, which, as the name suggests, converts your TeX file to a PDF. There is also XE LaTeX and Lua LaTeX, which are more advanced compilers that have more advanced features, especially if you're a LaTeX nerd like me. We'll only cover PDF LaTeX today. So that's, yeah, don't worry about that. How do I get this stuff though? How do I get the compiler? You need something called a LaTeX distribution. There are 2 or 3 main LaTeX distributions that people use. MikTeX is the most common for Windows operating systems. TeX Live is most common for Linux and Unix, and there's also a special Mac TeX distribution for Mac OS. Alternatively, what you can use is a website like Overleaf, and what that does is instead of you having to install all this stuff in your local machine, you can just pop into a browser and handle it all in the browser. And yes, the advanced features do include emojis. Fantastic. Oh, the XE LaTeX is important if you ever want to change your document's font to one in your computer rather than a package. So if you want to, say, typeset your whole presentation in Helvetica, then you're gonna need a more fancy font. Helvetica's got a package, but if you have a font that doesn't have a package, you're gonna want to do that. Use XE LaTeX using a package called FontSpec. What is a package? I'm jumping ahead of myself. Let's go through it slowly. All right. The key the key thing to note with LaTeX and TeX and whatever is that it's a program, right? When you write TeX, it needs to be correct. It needs to be correct code, or else LaTeX won't be able to figure out what you're trying to do, right? The word correct is a bit loose. Sometimes it can compile stuff and it comes out with weird output, but essentially you want to write correct code, right? So let's you will get syntax errors. You have to get used to that process, essentially, right? Because these syntax errors will help you become a much better LaTeX programmer, LaTeX writer, whatever. So let's begin with the most simple document we can. This is a TeX file, right? And it has 4 lines of code. It has a document class, a begin document, hello, and an end document. Let's run that. This is VS Code. It will automatically compile whenever I save, and this is the PDF output right here. And as you can see, that all it does is it prints hello on a page. If you scroll down, you can also see page number. But all it does is it prints hello. Right, there you go. There are 3 lines here of note. The document class is basically a way of saying what type of document is this. There is article, there is book, there is report, there is also AMS article, and a few others. The key point for they allow you to basically change the style of the document. There are many different types, but the key difference between article, book, report, etc. is the way that they handle sections and structure of the page. So articles don't have chapters, whereas books do, right? I'm getting into technicalities here. I know we just want to start putting text on a page first, right? But this is basically what a document class is, right? Begin document starts a new document, and everything that goes after begin document goes on the page. Hello, exclamation mark, I typed after, so that goes on the page. And document, nothing, right? So after end document, there should be nothing, ideally. I don't think there's any reason why I should have something after end document. What is the best way to present a Beamer PDF? I'm using Preview at the moment, but basically any PDF reader. Adobe Acrobat is a popular one for Windows users, right? I'm sorry, I will say hello to the world. Hello, world. Hello, UQCS. All right, there we go. I hope everyone's happy now. I'm certainly a lot happier. So, begin and end are the delimiters for something called an environment. And this is a really important concept when we're dealing with LaTeX, right? Beginning and ending an environment is basically everything you do in LaTeX. Everything you type that's not just text is probably done in an environment. And this, we basically, when we have a LaTeX document, we split it into two parts, right? These percentages are comments. This part is the preamble, and this part is the main document, right? So anything you type before this will be not printed on the document. Anything you type here will be printed on the document, right? So that's a key thing to know, right? If I save this, it should give me the same output, right? So let's start making things a little bit fancy, right? We want a title, we want an author, we want a date. Let's call this an amazing UQCS document, right? Who made this? Everyone made it, right? And the date is today. What is this? This is just a way of writing the current date. Like I could just write April 7, 2020, right? But obviously if you're compiling this document a million times, you don't want to have to do this every single time you compile. So put the date today, right? This did absolutely nothing. Why did it do absolutely nothing? Because I did not put this in the main document. This is in the preamble. These are all commands that run prior to the document's, the begin document, right? And I'm not saying anything about putting these into the document, right? So how do we do that? Oh, sorry. Yeah, so this is the code with some fancier words, right? We want to make the title. So let's put make title. We compile it and we get this. An amazing UQCS document by everyone on April the 7th, 2020. And below it immediately is the text. So congratulations, you've written a nice little document, right? There we go, this is the one I whipped up. Here's one I prepared earlier. This, right? Yeah, so the next thing we want in these documents is a bit of structure. So how would we do that, right? What we can do is we can just say, let's create a section. This is introduction, right? And let's create another section. Introduction, I don't know, results. UQCS is a fantastic organization, right? I save this and it will run it and it will create these two headers. There are sections, there are subsections, there are subsections, there are subsections, I think. And there are also chapters and parts depending on what sort of document you're making. Yeah, so as I mentioned earlier, articles don't have chapters and books do, right? And so you can basically just do this throughout your document, create sections, and be good. If you want to print a table of contents, you just need to put /table of contents, table of contents, right? And what that will do is it will print this, right? And that, yeah. If you wanted to, let's see, what if we made a subsection? Subsection, introduction to, right? That will show up in the table of contents like that, right? There. And if you're a keen-eyed viewer of this stream, you probably realize that a lot of the documents that you've been looking at in first year math or in CS have been made using this, right? This, like, as soon as you notice what a LaTeX document looks like, you will see it everywhere. And yeah, so this is all you need. We're done. That's it. That's the end of the talk. I'm just kidding. Of course not. We have this much to get through. So technically, you could just start writing a novel now, and then that's it. You just type paragraphs and keep going, right? But we're not going to do that, right? we're going to go through more fancy stuff, right? And this is where the environments come in. Everything here from pretty much then onwards is environment stuff, right? So yeah, the first environment we're going to cover is graphic X, or include graphics, right? So this requires us to use something called a package. And a package is just like an add-on, right? So you chuck it in the preamble. See, this is our little preamble line. I'm gonna write preamble above here, right? And we can just chuck it here. So we're gonna use the package graphic X. When we type this, it just basically tells the compiler, hey, we want to use this little package here called graphic X, and it has this wonderful thing called include graphics, right? This is much like include in your C files or whatever, right? So I want to include a graphic. Good idea. Include graphics. I have a meme. That's all I have on here. That puts a massive meme. Okay, so let me zoom out to what this actually looks like. This is the page, right? This is what the meme looks like, right? Yeah, it's not. If you put this on your document, it's a bit ridiculous, right? This is what's called an overfull. You want to avoid having stuff clipping the side of the page. So to solve this, firstly, there's two issues with this. Firstly, it's way too fucking big. Secondly, it's not centered, right? So the first thing we're going to do is we're going to create a center environment, right? What this tells us is that everything inside of here will be centered, right? If we save that, it will compile. It still looks big as shit because the image is so much bigger that it can't center it, right? But what we can do is hello. So I'm gonna just keep talking, and then when you can hear me, please let me know. Yes, I was talking about centering. Okay, sorry. Yeah, the internet, bit of a shame. I was talking about centering. So we can center it, right? We can center this, or we can put it in a figure and then center it. Why do we put it in a figure? Because we get other fancy stuff in a figure. Like you can caption, right? Yes, we can hear it. Okay, wonderful. Yay. So you can caption thingies. You can say this is a wonderful image, because it is. It's a wonderful image, right? And that will put a little caption here underneath saying figure 1, this is a wonderful image, right? And I've just realized I'm probably really going to have to speed this up because we have a lot more to get through. So this is essentially what a figure does. You can also replace this with /centering, because centering affects, okay, so there are two types. There's an environment and then there's a switch, right? So there's the begin center environment, which is an environment, and then there's the centering switch, right? The reason why you'd use a switch here is because we're currently sitting inside an environment. And normally, if you put centering /centering in the body of a text, then it will affect everything afterwards, right? Every single line of text that you write afterwards will be centered. We don't want that. We just want the figure to be centered, right? So whereas we wouldn't normally use this outside of an environment, if we're sitting in an environment, it's fine to put centering. Yeah, so that's what I'm saying. Caption just does that. So now if I want this to actually sit here, because you notice how there's this big gap, right? I want it to sit where it's meant to sit, right? Let's put this back, yay, right? Oh, sorry. You need to import the float package. So Now we have a figure that sits exactly where I put it, right? And this is typically what you want, right? So this is really important code, right? This will tell us, oh, put a figure, center it, include the graphics, ta-da, right? Cool. Now, tables. Tables are simple, but they're a bit of a pain to do because they require you to do a lot of stuff that isn't just pressing tab and enter, right? So firstly, if you want to have a table, so this is a tabular, right? There are 3 key components of a tabular. Firstly, you need to have defined what columns you're going to have. And then secondly, you need to have defined what the cells are. The cells are split, so the columns are split by ampersands, like this, and the rows are split by these. You'll see these a lot. This is generally the character that means new column, and this is generally the set of characters that mean new row. So if I wanted a table that says A, B, C, D, E, F, you'd do it like that, right? And I hope what have I done? Extra alignment tab has been changed. Oh, sorry, 3 columns. And what that would do is it would put a table that looks like that, right? Now this is not what a normal, this is a pretty ugly table, right? If you want to have a heading, you can just say heading 1, heading 2, heading 3, right? And then this will look fine, right? If we save it, it will make that. But if we want to have a line, we do hline, right? And that's how you make a table, right? Thanks, Koji. That's, yeah, the VS Code environment's really nice. What does CC mean? These are the columns, right? So each character represents a column here, and L means left aligned, C is centered, R is right aligned. So yeah. The C's are the alignment tabs. If I change this to L, it would align, as you can see here, all of the, sorry, that's a bit small. All of the columns would go left aligned, right? And as you can probably tell, once again, this table is not centered, so you can use a figure or a center to get that to be centered, like so. There you go, now it's centered. Also, if you want lines between your columns, chuck a pipe in between each column that you want to line, and that will allow you to, give me a second. My printer's gone on. Yeah, give me a second. And UQCS is a fantastic organization, that's correct. I've just turned off my printer. So that's a table. We can make tables. What if we want to make a list? That's the next thing people normally want, right? To make a list, you just need an enumerate environment, and that can be done very simply, like so, right? You have an enumerate, create an item, hello, 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 right? And an enumerate is a numbered list, and a itemize is a non-numbered list, so like a dot point, right? So if I were to copy this here, chuck in an itemize, right, and then do that, then we have essentially a numbered list and a non-numbered list. So this would be, yeah, very useful if you want to make shopping lists in LaTeX. Now let's try to rush through this formatting stuff a bit. So we have font sizes, right? So the default font size is 10 point, right? If you want to make the font a little bit bigger, what you can do is you can specify a font size as an option to the thing, and you can see it's made it slightly bigger if we do that, right? 11 point there, 12 point there. Another useful feature is you can also say that it's an A4 document, and that will adjust it, right? Because LaTeX defaults to US letter paper size for some reason. But yeah, yeah. Printers are cancelled. Yeah, this is what happens when you have a shared printer. Anyway, Now let's do some more formatting. I'm going to go back to 10 point and I'm going to go back to US letter. So I'm just going to leave all of the options like that, right? Now we have three things that you normally want to do when you're writing documents is you want to bold it, you want to underline, and you want to italicize, right? To bold text, you do the text is bold, right? And that gives you a bold thing here. So you use text BF, text IT, the text is italic. There you go. Let me just turn on word wrap. And then the text is underlined, right? If we save this, where's it? There we go. So we have the text is bold, the text is italic, and the text is underlined, right? This is very cool, but what's even cooler is the fact that you can do toggles. So these are the toggles, right? I'd mentioned switches before and how you can make your entire document centered if you want. But if you want to make your entire document bold, if you're really angry, right? Or if you want to make your entire document italics because you're really poetic, then you can use BF series IT shape underline, right? So that's text. Oh yeah, you can also do left and right and center aligned by using environments. I've already gone through center, but these are the same. And these are the switches. So if you want to make your whole document ragged left, ragged right, whatever, etc. So that's the end of text formatting. So now let's get into packages. There are 4 sets of packages I want to cover roughly in the rest of the talk. Listings, AMS packages, geometry, and bib.latex. Listings is for writing code and stuff. AMS is for writing maths. Geometry is for page formatting stuff, and then bib.latex is for bibliographies, right? So as computer science, software engineering, IT, or whatever similar field students, you will probably find the most use out of listings. Listings are essentially just ways of writing code, right? So it's a package. You need a listings package, right? And then you want to write, if you want to write code, you wrap it in a listing environment, or specifically an LST listing environment for some reason, right? So let's copy this code here, right? And then we get a code snippet here. It says hello world, and we print hello world, right? Hang on, give me a second. Yeah, okay. So this is cool, but what if you want to have highlighting for Python, for example? This is a piece of Python code. I want it to be written like it's Python code, right? So we can just do language equals Python as an option to the listing. And yeah, as you can see, everything's about environments, everything's about options. This is a very, very common pattern when you're dealing with LaTeX, right? You can see how it bolds stuff. Yeah. Do you want code from another file? You can just do LST input listing, right? And this will put in a copy of that file, right, into your document. And it will format it if you obviously want to put the option if you so desire. Oh no, before. And that will print out the document like so, right? Yeah, so this will allow you to put code from other files in, which is really useful if you're writing assignments that need you to submit code, because you don't want to be copying code into your document all the time, right? So that's listings. I'll take a quick 30-second break. Give me a second. I'm back from my short break. So LaTeX, as you probably know, is a fantastic tool for writing math. Its syntax is super simple and very easy to get the hang of, and I'm going to go through basics here. I'm going to skim through it. This is what I'm most used to writing, because I've done all my math assignments since I basically started at uni in LaTeX, and yeah, I've gotten a lot of practice with it. We need some packages. We need the AMS packages, so I'm just going to import them all like this. So you can import multiple packages like that, and that will import all of the packages at once, right? So to write math, there's 4 ways, or 2 ways of doing it, really. You have the inline math and the display math. You can also write display math like this. This is where you put the stuff. And you can also write inline math like this. this way I put the stuff. But normally I've seen most people just write math like this is inline, and then this is display, right? What is inline? What does display mean? If I type sine squared theta plus cos squared theta equals 1, that will go in inline, right? So if I put it here, right, it's going to sit on the same line, right? Whereas if I put display math, I can do, right, and this will go on its own separate line, right? So that's what's the difference. To write basic symbols, so I'll just go through a few symbols. So plus and minus are written just by typing plus and minus. If you want times, you want slash times. If you want fractions, you can write them like that, right? If you want a square root, for example, you can do square root of ABC, and that will print a square root of ABC. I'll zoom in here so you can see it, right? If you want square root of DEF, obviously same thing, right? If you want trigonometric functions, you can just do sine of x plus tan of x, right? And then it just pops up like that. If you want exponentials and logarithms, you can just do e to the x or slash x, right? Notice how there's a space between the operator and the thing that it's running on. And logarithms can be done either using log x or ln x, depending on your convention. To write Greek letters, you just do delta, alpha, gamma, whatever, right? And that will print the lowercase. If you were to type the same thing, alpha doesn't have a capital, but gamma does, then it will print the Greek uppercase. As I mentioned earlier, powers and subscripts are handled by putting in x squared x1. So this will put a tiny little number there, and then the underscore will put in a smaller number, right? You may notice I'm omitting these brackets. If you have a single character argument to the power or this one or any of these, right? You don't need to put the brackets around. I should probably put the brackets in to stop confusing people, but you don't need the brackets if it's one character. If I put in x to the power of 22, it would put x to the power of 2 and then a 2, right? Because it guesses that it has one character. If you want both of them to pop up there, you need to put brackets around it. I hope that makes sense. For operators where you have multiple limits, for example, if you have an integral from minus infinity to infinity, right? Then you can do that by putting in a subscript next to the operator and then a power, so they go next to each other, right? Sorry, I'm just doing a quick crash course on all of this stuff here. Apologies if I'm going quickly. Let me know if you have any questions. If you want a fraction, you can, as I mentioned, do that. If you want parentheses around the fraction, if you put it like this, it won't make the parentheses stretch all the way. So you want to put in some sort of, there's a command that's used to put in, to stretch the things on the side, and that's the slash left and the slash right. So you put slash left before the thing that you have on the left, slash right before the thing you have on the right, and then that will essentially stretch like so, right? So there's matrices. It's just the same as tables. You don't have this thing. I won't type it out for the sake of time. There's alphabets as well. So if I'm just typing regular math, right, so letters, right, they'll pop up like italics, right, because they're variables italics. That's the convention. Sometimes you want them to be different alphabets. This is the list of alphabets you can use. There are more. The most common one is if you're talking about the real numbers, you might need to write slash math BBR, and that what that will do is it will put a math blackboard bolded R into the document. And there's also math BF, math cow, math frac, And you can start getting used to writing more complicated equations like this. They're all just building blocks of stuff that we've covered: fractions, integrals, e to the power of something, fractions, changing the font. And yeah, one thing I highly recommend if you want to practice writing math, then what you can do is you can go to Technique. This is a really, really useful game that you can use to practice writing complicated equations and then get more used to there's align environments too. So if you want to have multiple lines of math lined up together, you can chuck them in this align environment, and then you can use the alignment characters to line up all of the equals, and then you can get something that looks somewhat like this. You can also create theorems. How would you do a theorem? You first, in your preamble, you can define a theorem environment like this. Theorem, right? And then once you've done that, you can go into your document, select begin theorem, and then write this is a theorem, right? And what that will do is, if you zoom out a little bit, create a theorem called theorem 1. It numbers the theorems, and then puts it there. And you can also do proofs like that. So proofs, I'm basically just, notice how there's a lot of common stuff between all of these. You're just beginning environments, chucking in a name of the environment based on what it is, and then you type some text in and maybe a bit more alignments to make it fit. That's the general theme of things. I've gone over math probably a bit long. There's a lot of math stuff. Keep practicing. This is very useful if you're doing a maths degree or even like a maths 1051 or whatever. But yeah, the syntax is quite simple. Now I'm just going to wrap up some quick little asides, things like that. If you want to have a footnote, so let's say this is a document, right? But you're a bit worried about whether this is actually a document or not. Actually, I'm not sure if this is a document. What this will do is it will put a little footnote here which says, actually, I'm not sure if this is a document. This is a pretty cool little trick that you can use in your documents. For bibliographies, I'm going to skip over this because bibliographies are really complicated, but essentially what you have is you have a .bib file that you can create from your bibliography referencing manager or whatever, and then you can import it, add bib resource. And then whenever you have something you want to reference in your document, you can /cite. And yeah, that's a very useful thing to do. You don't have to manage or keep adjusting references anymore. It's super simple. BibTeX files normally look like this, where you specify the fields and then it will figure out the formatting for you. A little other thing to note, you can include files, other TeX files, in your own LaTeX files. I'll show that later, but essentially it's a very simple idea. You do /include some file.tex, right? And that file will go right there where you put it. Everything inside it, all the environments, all the fonts, everything will go inside it, right? You can also do input. The difference between the two is that input literally just gets all of the text from that file and puts it in this document, whereas include is a bit fancier, where it actually means you don't have to compile the whole document every time, right? It's a bit smarter, and it will create its own separate, to adjust the margins of your page, what you can do is you can essentially use the geometry package. Have I imported it yet? No. So the geometry package is very useful if you have a document. So the default margins for LaTeX are a bit, hang on. Sorry, give me a second. I think oh yeah, can't do that. Right, they're a bit crazy. If you zoom out here now, so you can see where the page borders are. There's a lot of gap here, right? a lot of space. So you can actually specify custom margins by using the geometry package. And you can say the margin is 2 centimeters, which is very small. And that will put everything quite close to the margin, as you can probably see in this tiny little. Yes. And yes, the slides will definitely be available after the talk. I realize that this is a lot of stuff to cover. I'll be posting it straight away in the events chat in the Slack. Yeah, so fancy headers, this is probably not that important, but you can essentially specify your own headers using the fancy header package, and that can put custom text in the top and bottom. This is TeX. This is a way to draw diagrams. Don't worry about this code at all. Essentially, you can just make diagrams using pure LaTeX, which is really cool, but obviously we don't have time to cover all of this. These are all packages for editing the formatting. Yeah, they're very in-depth. I don't have time to cover them. And one final mic drop moment. This entire slideshow was made in LaTeX, believe it or not. So all this, right? This is all just LaTeX, right? Let's see if I can get the file. Right. This is the file I wrote for today's talk, right? A few hundred lines of LaTeX, and this is everything here compiled to this presentation, which I think is really cool. The fact that you can just write LaTeX stuff and it will make a nice, really neat presentation. Yeah. Now there are plenty of other packages for specialized needs. I obviously don't have time to cover them, but you might be interested in physics package if you're a physics student, for example. If you want to draw fancy plots of graphs, you can use PGF plots, and there are many more packages. So, to wrap up this talk, I'm going to show a setup that I have that uses all of the things I just mentioned. This is my personal lecture note setup. Essentially, so this is the tree of my file structure. So I have a folder called LaTeX, right? And in that folder, I have folders for assignments, courses, a header file, some other stuff, and yeah, some more stuff. The idea is that I have a single header file, which I input at the start of every document that has all of the formatting I want, right? And if I want to change, sorry, give me a second. If I want to change the structure of a document, like the formatting of a document, I can do that all just with a header.tex, and that will have all of the preamble in it. I'm essentially separating the preamble from the document, right? So in each folder, I have files for the course or whatever file I'm doing, whatever tech this is, and it imports the preamble, right? So this is my setup. I will show my setup now. So let me switch over to here. So this is my lecture notes for a course I'm doing. This is the input, so this is the header file. And if I look at the header file here, you can see a lot of these use packages and document classes and things like that. And that's essentially, that's where I import everything, and this is where I set my geometry and things like that, right? The title, the author, and the date go here, just like I've shown you in the sample documents, right? And I begin the document here, I make the title, I make the table of contents, and then I include the subfiles, right? So I'm putting all of the files here. So these are all little files that have a content of each lecture, right? And then these will go, I include them all one by one, like that. And that's the outcome, right? Yeah, that's basically it. So all of these lectures get compiled into one. That's it. You can now write modular, clean documents, and without worrying too much about page layout. And you can even write papers, your assignments, theses, and you can develop your own templates to suit your needs. As I've shown you, that's an example of a way you can do it. LaTeX is a massive and wonderful rabbit hole that you can dive into. So you can go to the Stack Exchange. That's a very common, it's like Stack Overflow but for LaTeX essentially, and you can read the LaTeX wiki book as well. Those are both really good resources for learning more about LaTeX. And if you have any more questions, you can ask in the UQCS Slack channel /LaTeX, or you can just DM me at MCL on Slack, and I'm happy to answer any questions. So yeah, that's it. Thanks so much for that. I'm happy to answer any questions that you might have about LaTeX or this or the system or whatever. My preamble, yeah, I'm happy to upload my preamble. So it's a bit messy. I might be able to whip it up into a Git repository, and hopefully that's useful. It's a bit messy. I'd like to clean it up a little bit, and there's a lot of stuff in there which you might not work at first, but I'll happily share it. And if you have any questions about how stuff works, please let me know, and I'm happy to answer them. If there's any other questions. No worries, Tom. Thanks. I'm glad you enjoyed the talk. No worries. Thanks everyone. If there's no more questions, I'm happy to wrap up the talk. As I mentioned, you're more than welcome to contact me on the Slack or whatever if you have any more questions about LaTeX, how it works, if you want to make documents a specific way. Yeah, and I will put up my I'll put up the preamble and the document. I'll put up a template repository, so you can have a look at how preambles work, how you can import, you can have modular documents. So yeah, I'll wrap it up now. Thanks so much everyone for watching, and I appreciate it. See you all.